Okay, now here we're going to be working backwards. We're going to be starting with our graph, working backwards to find the A, B, C, and D. In all these, you want to always find your cosine, even if the problem's asking for your sine. It's a lot easier to find the value of C. Well, the formula for finding A is always max minus min divided by 2. The max and min always refer to the y values of your points. So you're maxing out at a height of 5, bottoming out at a height of -2. So you plug in your 5 for your max, your -2 for your min, and then we end up getting our A to be 3.5, which means we're going to go 3.5 units above and below the horizontal line that cuts your graph in half. To find that horizontal line that cuts your graph in half, once again, you want to use your max and your min, but now you're going to add them together. So you take your 5 plus your -2 divided by 2, and then that gives you 1.5. 1.5. So the horizontal line that cuts your graph in half is at a height of 1.5. And how far you go above and below that horizontal line is the amplitude, which is your 3.5. So that's how it shows up on your graph. We don't need that though for the sake of what we're looking at. We also need to go ahead and find our period. Well, our maximum to our maximum would be one complete period. When we go ahead and go from here over, we know that's pi. When we go from here this way, that's a sixth of a pi. So from a pi to a sixth of a pi, it's pi minus a sixth of a pi. We get 7 pi over 6. Well, we can then go ahead and use our peanut butter equation. We know our period. We don't know b, but we do know we need to get our normal period of 2 pi. So we go ahead and use that to be able to find the value of b. So we multiply both sides by 6 divided by 7 pi, and we get 12 over 7. Well, we had figured out a. A was your 3.5. We had figured out b. That's your 12 sevenths. We had figured out your d. That was your 1.5. Now, to figure out c, the easiest way to do that is say, well, if I wasn't shifted left or right, my cosine would have a maximum right here. It always has maximum on your axes unless it's changed. But here, you got to shift it left a sixth of a pi to get to your maximum. You know, if you're shifting left, you got to go plus, and we had to move it a sixth of a pi. So here we're looking at tide and how it's affecting the river. You're starting out at 15 degrees at night. It's cooling off, then it's rising back up to a height of 50, and then cooling off again. And that's one complete period. Now, your graph would look basically like what we have over here. There's enough information over here to let you know how to graph that. You know one complete period is 1 day, so you know halfway through that would be 12 hours. Halfway between here and here would be at 6 in the morning, and that's when it's the coolest. Halfway between here and here would be 18 hours after midnight or 6 at night, and that's when it's the warmest. Having this graph gives us a visual of what's going on. You can see that your maximum is 20, your minimum is 10, so we can use our formula for A, max minus min divided by 2, and then we end up getting 5. And you can see from your graph, you go 5 units down and 5 units up from that horizontal line that cuts it in half. Your max plus your min divided by 2 is how you find D. So then you end up getting 15, and you can see that in your graph that 15 is the horizontal line that cuts your graph in half. Well, we still need to find B and or not B, yeah, B and C. Well, we know B is affected by your period. Your period starts out here and goes until you get to 24 hours. So your period is 24. So we're going to use our peanut butter equation equals 2 pi. So we'll go 24 times B equals 2 pi. Solving that by dividing both sides by 24 gives us a 2 pi over 24, which reduces down to a pi over 12. Well, we'd figured out A was 5. We just figured out B to be 12, 1/12 of pi, and we had figured out D to be 15. Once again, C is how far you have to move your max. When we look at our graph, when we're looking at our cosine would have a maximum here. Your cosine's always right on your axes. You're not moving left or right at all unless you have a phase shift. So your maximum would be here. Well, we need to move it from here all the way over to here, which means we went 18 units to the right. So C is 18. And since we're moving it to the right, you got to go and subtract, with C being 18. This is the title one. I almost think I said that on the last one. Sorry about that. The last one was just dealing with temperature change. Okay, here's your times, here's your depth. Time and your depth, time and your depth, time and your depth. If you want, you can go ahead and sketch your graph of all this, but you don't have to. You can go ahead and use your idea of, to find A, max minus min divided by 2. You'll realize in your chart here that your maximum value is here. Your minimum value is right here. Now, we'll go our maximum of 34.3 minus your min of 18 divided by 2, and we get A to be an 8.15. Well, since we're dealing with A and B or A and D deal with the max and the min, let's go ahead and plug our max in and our min into our formula for D, and we get D to be 26.15. Now, we know your period goes from our maximum, which occurs here, to our other maximum, which occurs here. Well, how much time occurs between 3 in the morning and 4 in the afternoon? Well, 3 in the morning to 4 in the afternoon is 13 hours. So your maximum or your period is 13 hours. So your peanut butter equation, 13 times b is equal to 2 pi. We are then able to get 2 pi over 13 for your b value. So we know A is at 8.15, B is at 2 pi over 13, D is at 26.15. Well, once again, C is how far you have to go to get to your maximum. Well, our maximum is occurring right here at 3 in the morning. Initially, without any phase shift, it would be occurring at midnight. So how far do we have to move it? Well, we have to move it 3 hours. So that means C is 3 to get to your maximum at 3 in the morning.